According to the Massachusetts State Electrical Code, based on the 2023 National Electrical Code, all 120-volt, 15 and 20 ampere receptacles in bathrooms and kitchens must be protected by a ground fault circuit interrupter device. To comply with the code, there are several options. Firstly, you can install ground fault circuit interrupter circuit breakers. This involves replacing the existing circuit breakers for the bathroom and kitchen circuits with ground fault circuit interrupter circuit breakers. These breakers will protect all receptacles on that circuit. Secondly, install ground fault circuit interrupter receptacles in all bathroom and kitchen outlets. This will provide protection only for the individual outlets where they are installed. Thirdly, use a combination of both. You can protect some outlets with ground fault circuit interrupter circuit breakers and others with individual ground fault circuit interrupter receptacles to achieve full coverage. The most comprehensive and reliable solution is to install ground fault circuit interrupter circuit breakers in the service panel for the bathroom and kitchen circuits. This will provide ground fault circuit interrupter protection to all outlets on those circuits, including outlets that may be added in the future or that are not easily accessible for ground fault circuit interrupter receptacle installation. If you are installing ground fault circuit interrupter circuit breakers, make sure they are compatible with the existing electrical system. Ground fault circuit interrupter devices should be tested regularly to ensure they are functioning properly. Ground fault circuit interrupters are designed to protect people from electrical shock. They do this by monitoring the amount of current flowing through a circuit. If there is a difference of even a few milliamperes between a current flowing to and from an appliance, the ground fault circuit interrupter will trip, cutting off the power. This can happen if there is a fault in the appliance, such as a frayed wire touching the metal casing. Ground fault circuit interrupters are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoors. There are two main types of ground fault circuit interrupters: receptacles and circuit breakers. Ground fault circuit interrupter receptacles are installed in place of standard electrical outlets. They have a test button and a reset button on the front. Ground fault circuit interrupter circuit breakers are installed in the electrical panel. They protect the entire circuit. When choosing a ground fault circuit interrupter, it is important to select one that is rated for the voltage and amperage of the circuit. It is also important to choose a ground fault circuit interrupter that is listed by a qualified testing laboratory such as Underwriters Laboratories. Installing a ground fault circuit interrupter is a relatively simple task that can be done by a qualified electrician. However, it is important to follow the manufacturer's instructions carefully. To test a ground fault circuit interrupter receptacle, press the test button. The reset button should pop out. If the reset button does not pop out, the ground fault circuit interrupter is not working properly and should be replaced. To reset a ground fault circuit interrupter receptacle, press the reset button. If the ground fault circuit interrupter trips again, there is a problem with the circuit or the appliance that is plugged into the receptacle. The problem should be corrected by a qualified electrician. Ground fault circuit interrupters are an important safety device that can protect people from electrical shock. They are required in many areas, and they should be tested regularly to ensure that they are working properly. The National Electrical Code, or NEC, is a set of standards for electrical wiring and equipment in the United States. It is published by the National Fire Protection Association, or NFPA. The NEC is updated every 3 years. The NEC is not a law, but it is widely adopted by state and local governments. This means that the NEC is the law in many areas. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is divided into chapters, articles, and sections. Chapter 1 covers general requirements. Chapter 2 covers wiring methods. Chapter 3 covers overcurrent protection. Chapter 4 covers grounding. Chapter 5 covers equipment installation. The NEC is a complex document, but it is essential for anyone who works with electricity. The NEC helps to ensure that electrical wiring and equipment are installed safely and correctly. There are several ways to comply with the NEC. One way is to follow the NEC requirements exactly. Another way is to use equipment that is listed by a qualified testing laboratory, such as underwriters' laboratories. Listed equipment has been tested and found to meet the NEC requirements. It is also important to have electrical work inspected by a qualified electrical inspector. Electrical inspectors can help to ensure that electrical work is done safely and correctly. The NEC is an important tool for protecting people and property from electrical hazards. By following the NEC, you can help to ensure that electrical wiring and equipment are installed safely and correctly. In addition to the NEC, there are also state and local electrical codes. These codes may be more stringent than the NEC. It is important to check with your local government to find out what electrical codes are in effect in your area. Working with electricity can be dangerous. It is important to take precautions to protect yourself from electrical shock. Always turn off the power before working on electrical wiring or equipment. Use insulated tools. Wear rubber gloves and shoes. Never work on electrical wiring or equipment when you're wet. If you are not comfortable working with electricity, hire a qualified electrician. Electricity is a powerful force. It can be used to do many things, but it can also be dangerous. By taking precautions and following the NEC, you can help to ensure that you and your family are safe from electrical hazards. Ground fault circuit interrupters are a critical safety component in modern electrical systems, especially in areas prone to moisture. Understanding their function types and proper installation is essential for ensuring electrical safety and code compliance. The basic principle behind a ground fault circuit interrupter is the monitoring of current balance. In a standard electrical circuit, the current flowing to an appliance should equal the current returning. A ground fault occurs when some of the current leaks to ground, often through a person touching a live wire or a faulty appliance. Ground fault circuit interrupters detect this imbalance and quickly shut off the power, preventing electrical shock. There are two primary types of ground fault circuit interrupters: receptacles and circuit breakers. Ground fault circuit interrupter receptacles are designed to replace standard outlets, providing localized protection. These are commonly used in bathrooms, kitchens, and outdoor areas. Ground fault circuit interrupter circuit breakers, on the other hand, are installed in the electrical panel and protect the entire circuit. This offers broader protection, safeguarding all outlets and devices connected to that circuit. When selecting a ground fault circuit interrupter, several factors must be considered. Firstly, the voltage and amperage rating must match the circuit being protected. Most residential circuits are 120 volts, but higher voltage circuits may require different ground fault circuit interrupters. Secondly, the ground fault circuit interrupter must be listed by a recognized testing laboratory, such as underwriters' laboratories, ensuring it meets safety standards. Thirdly, the type of ground fault circuit interrupter should be chosen based on the specific application. Receptacles are ideal for localized protection, while circuit breakers offer comprehensive protection for an entire circuit. The installation of ground fault circuit interrupters should be performed by a qualified electrician to ensure safety and compliance with electrical codes. For ground fault circuit interrupter receptacles, the installation process involves removing the old outlet, connecting the wires to the new ground fault circuit interrupter receptacle, and securing it in the electrical box. It is crucial to follow the manufacturer's instructions carefully and ensure proper wiring connections. For ground fault circuit interrupter circuit breakers, the installation process involves turning off the power to the circuit, removing the old circuit breaker, connecting the wires to the new ground fault circuit interrupter circuit breaker, and installing it in the electrical panel. This task requires more expertise and should only be performed by a licensed electrician. Regular testing of ground fault circuit interrupters is essential to ensure they are functioning correctly. Ground fault circuit interrupter receptacles have a test button that simulates a ground fault. Pressing this button should trip the ground fault circuit interrupter, cutting off the power to the receptacle. The reset button can then be used to restore power. Ground fault circuit interrupter circuit breakers can be tested using a similar method, either with a built-in test button or by using a ground fault tester. If a ground fault circuit interrupter fails to trip when tested, it should be replaced immediately. Several common issues can arise with ground fault circuit interrupters. Nuisance tripping, where the ground fault circuit interrupter trips for no apparent reason, can be caused by faulty appliances, wiring issues, or even moisture. Identifying and resolving the underlying cause of nuisance tripping is crucial to avoid disrupting power and ensuring safety. Another issue is a failed ground fault circuit interrupter, which may not trip even when a ground fault occurs. Regular testing can help identify failed ground fault circuit interrupters, which should be replaced promptly. The National Electrical Code plays a vital role in ensuring electrical safety by establishing standards for ground fault circuit interrupter protection. The NEC requires ground fault circuit interrupter protection in various locations, including bathrooms, kitchens, outdoor areas, and construction sites. These requirements are designed to minimize the risk of electrical shock in areas where moisture or other hazards are present. Compliance with the NEC is essential for ensuring the safety of occupants and preventing electrical accidents. Failure to comply with the NEC can result in fines, penalties, and even legal liability. Staying informed about the latest NEC requirements and ensuring proper ground fault circuit interrupter installation and maintenance are crucial for maintaining electrical safety and code compliance. Understanding the function, types, installation, and testing of ground fault circuit interrupters is essential for ensuring electrical safety and code compliance. By following best practices and staying informed about the latest NEC requirements, you can protect yourself and others from the dangers of electrical shock. Remember to always consult with a qualified electrician for any electrical work and to prioritize safety above all else. Ground fault circuit interrupters are not a substitute for proper grounding and other safety measures, but they provide an extra layer of protection that can save lives. In addition to the specific requirements for ground fault circuit interrupters in bathrooms and kitchens, the National Electrical Code also addresses ground fault circuit interrupter protection in other areas. For example, all 120-volt, 15 and 20 ampere receptacles in readily accessible outdoor locations must be ground fault circuit interrupter protected. This includes receptacles on patios, decks, and balconies. The NEC also requires ground fault circuit interrupter protection for receptacles serving swimming pools, spas, and hot tubs. These requirements are designed to protect people from electrical shock while they are in or near water. Furthermore, the NEC mandates ground fault circuit interrupter protection for construction sites. All 120-volt, 15 and 20 ampere receptacles that are used by construction workers must be ground fault circuit interrupter protected. This helps to prevent electrical accidents caused by damaged cords, wet conditions, and other hazards commonly found on construction sites. In addition to receptacles, the NEC also requires ground fault circuit interrupter protection for certain types of equipment. For example, electric vehicle charging stations must be ground fault circuit interrupter protected. This is to prevent electrical shock in case of a fault in the charging equipment or the vehicle. Portable generators used in residential areas also require ground fault circuit interrupter protection to ensure safety. When installing ground fault circuit interrupters, it is important to follow the manufacturer's instructions carefully. Incorrect wiring can render the ground fault circuit interrupter ineffective or even create a safety hazard. It is also important to use the correct type of wire and connectors to ensure a safe and reliable installation. After installing a ground fault circuit interrupter, it is essential to test it to verify that it is working properly. This can be done by pressing the test button on the ground fault circuit interrupter. If the ground fault circuit interrupter trips, it is working correctly. If it does not trip, it should be replaced immediately. Ground fault circuit interrupters should be tested regularly, at least once a month, to ensure that they are functioning properly. This is especially important in areas where there is a high risk of electrical shock, such as bathrooms and kitchens. In addition to testing, ground fault circuit interrupters should also be inspected regularly for any signs of damage or wear. If a ground fault circuit interrupter is cracked, broken, or otherwise damaged, it should be replaced immediately. It is also important to keep ground fault circuit interrupters clean and free of debris. Dust, dirt, and other contaminants can interfere with the ground fault circuit interrupter's operation and reduce its effectiveness. When cleaning ground fault circuit interrupters, use a soft, dry cloth. Do not use water or any other liquids, as this could damage the ground fault circuit interrupter. Ground fault circuit interrupters are an essential safety device that can protect people from electrical shock. By following the recommendations outlined, you can ensure that your ground fault circuit interrupters are installed correctly, tested regularly, and maintained properly. This will help to keep you and your family safe from electrical hazards. Remember that electrical work can be dangerous. If you are not comfortable working with electricity, hire a qualified electrician. A qualified electrician has the knowledge, skills, and experience to install and maintain electrical systems safely and correctly. Hiring a qualified electrician can help to prevent electrical accidents and ensure that your home or business is up to code. In addition to ground fault circuit interrupters, there are other safety devices that can help to protect people from electrical shock. Arc fault circuit interrupters, or RFCIs, are designed to protect against fires caused by electrical arcs. Surge protectors are designed to protect electronic equipment from damage caused by power surges. Smoke detectors are designed to detect smoke and provide an early warning of a fire. Carbon monoxide detectors are designed to detect carbon monoxide, a colorless, odorless gas that can be deadly. By installing and maintaining these safety devices, you can help to protect yourself and your family from a variety of hazards. Electrical safety is an important topic that should be taken seriously. By following the recommendations outlined and taking other precautions, you can help to prevent electrical accidents and ensure that your home or business is safe. Ground fault circuit interrupters are a cornerstone of electrical safety, particularly in environments prone to moisture or water exposure. Their ability to quickly detect and interrupt ground faults significantly reduces the risk of electrical shock, making them indispensable in residential, commercial, and industrial settings. While ground fault circuit interrupters offer substantial protection, it's crucial to understand their limitations and use them in conjunction with other safety measures. Grounding, for instance, provides a safe path for fault current to return to the source, helping to trip circuit breakers and further minimize shock hazards. Regular inspections of electrical systems, including wiring, outlets, and appliances, are also essential for identifying potential problems before they escalate into dangerous situations. The effectiveness of ground fault circuit interrupters hinges on their proper installation and maintenance. Incorrect wiring can render them useless, while neglected testing can lead to undetected failures. It's therefore imperative to engage qualified electricians for all electrical work, ensuring compliance with the National Electrical Code and adherence to best practices. Furthermore, educating occupants about the purpose and function of ground fault circuit interrupters empowers them to recognize potential issues and take appropriate action. Encouraging regular testing and reporting any abnormalities to qualified personnel can contribute to a safer environment for everyone. As technology advances, new and improved ground fault circuit interrupter devices are continually being developed. These advancements may offer enhanced sensitivity, improved reliability, or additional features that further enhance electrical safety. Staying abreast of these developments and incorporating them into electrical systems can provide an added layer of protection. Electrical safety is a shared responsibility. By understanding the risks, implementing appropriate safety measures, and promoting a culture of awareness, we can collectively reduce the incidence of electrical accidents and create safer environments for ourselves and future generations. Ground fault circuit interrupters are just one piece of the puzzle, but their importance in preventing electrical shock cannot be overstated. Remember to always prioritize safety when working with electricity, and never hesitate to seek professional assistance when needed. By taking these steps, we can ensure that electricity remains a safe and reliable source of power for all.